Now we're going to look at Lewis structures of molecular compounds. There are different approaches to drawing Lewis structures. This is the one in the book, and I think it's a pretty good one. So that's what I'll be using in my lectures. So this is not a set of hard and fast rules, but it's just a guide. So you start by writing the correct skeletal structure of the molecule. So you figure out, well, how many atoms of this element, how many atoms of that element, and how are they going to be connected? Which one's going to be in the middle? Which one's going to be on the outside? And just as a guide, hydrogens are always terminal, meaning they are on the outside of the structure because they can only form one bond. So they can't be in the middle and be bonded to multiple things. Also, more electronegative atoms are generally in terminal positions. Next, you calculate the total number of electrons for the Lewis structure by adding up the valence electrons for each atom. So just add them up. If you have ion, it has a charge. So it has like a -2 charge, that means you add 2 electrons. +3 charge, you subtract 3 electrons. So now you've got your number of valence electrons, and you're going to spread the electrons around, trying to get octets for everybody, or a duet for hydrogen. So we've got a single bond connecting things, and we have to count that. The single bond is 2 electrons. Sometimes it's all good and you've got enough electrons to give everybody an octet and you're done. Other times you run out of electrons, and so if you have atoms that lack an octet, then you need to form double or triple bonds as needed. More sharing is required. So let's do some examples. Write the Lewis structure for carbon monoxide. So step 1 is the skeletal structure. So this one, there's not too many options. There's only 2 atoms. They have to be connected to each other, right? So I've got those connected to each other. And the next step is to count up valence electrons. So I have 1 carbon atom. Carbon has 4 valence electrons. And I have 1 oxygen, and that has 6 valence electrons. And that adds up to 10. So I have 10 valence electrons. Now I'm going to start putting valence electrons around here. And I do it by counting by 2. So here we have 2 for this single bond. So that's 2, 4, 6, 8, 10. I ran out of electrons and nobody has an octet. So what that means is we need to do more sharing. To avoid counting again, we're going to think about taking this pair, this lone pair, and moving it over here to be a bond. So we haven't changed the number of electrons, we're just shifting them around. So I'm going to take one of the lone pairs and I'm going to put it in there and have it be a bond. So I still have 2, 4, 6, 8, 10 electrons, right? If we look at carbon, carbon has an octet now. It has 2 lone pairs and 2 bonding pairs, 8 valence electrons. But oxygen doesn't have an octet. So this is the poor oxygen, and this is the rich carbon, and so the rich carbon needs to share more, right? So we'll take a lone pair from carbon who has enough and share with oxygen. So I'm going to move that lone pair to become another bonding pair. I still have 10 electrons, 2, 4, 6, 8, 10. Now I have 8 around each, because both of them count the 6 in the bonding pairs plus the 2 over here. That's the Lewis structure for carbon monoxide. Any questions? So let's do H2CO. This one's a little more complicated. So we've got two hydrogens. We have a carbon and an oxygen. So it's a little hard to know, is one in the middle and the others are surrounding it? And that's a good first guess. Put one in the middle and attach everybody else to it. Typically that's how they go in 1A. So can I put a hydrogen in the middle? No, because hydrogen can only make one bond. So then should I put carbon in the middle or oxygen? Carbon, because oxygen is more electronegative, and the more electronegative elements tend to be on the outside. So I'm going to put carbon in the middle, and I'm going to attach an oxygen to it, and a hydrogen to it, and another hydrogen. So I have H2CO. Sometimes you draw the skeleton and realize afterwards, that was wrong. And you just do it over again. Then I have to add up my valence electrons. So I have two hydrogens, they each have one valence electron. I have carbon with 4, and I have oxygen with 6. And so this is going to be 12 valence electrons. So first I'm going to count these single bonds. So that's 2, 4, 6, 8, 10, 12. And exactly how you distribute them doesn't matter. I tend to just kind of go around in a big circle instead of filling up one guy and leaving somebody empty. Is everybody happy here? No, who's unhappy? Oxygen. Oxygen only has 6 valence electrons in this structure. We need to give it 8. Carbon has 8. 2, 4, 6, 8. So carbon has enough. Carbon needs to share with the one that doesn't have enough. Right? That's how it goes with people, right? You've got lots of food and this person doesn't have any food, and so you share some of your food. So this carbon's going to share its lone pair of electrons. So I'm going to take that lone pair and make it into a bonding pair. Same number of electrons, I'm just moving them around. 2, 4, 6, 8, 10, 12. Now oxygen has 10, and carbon has 10, and hydrogen has 2. If hydrogen has a bond, it's happy. So hydrogen, you just really don't need to worry about very much. Any questions? So if we're doing polyatomic ions, we're going to add an electron for every negative charge, subtract an electron for every positive charge, and then we're going to put brackets around the Lewis structure and put the charge on the outside, because that's just what we do. So let's do ClO-. This is hypochlorite ion. Well, again, there's only 2 elements here, so 2 atoms. There's chlorine and oxygen. And we'll put a single bond between those because that's the minimum, right? If it's part of the molecule or the polyatomic atom ion, it has to be bonded in there. And then we're going to count valence electrons. So how many valence electrons does the chlorine have? 7. And oxygen has 6. And then what do we do with this charge? That means there's an extra electron, plus 1. So that means I have 12 valence electrons that I can show in this structure. I'm sorry. I can't add today. Yes, it's 14. Thank you. So starting here, this is 2, 4, 6, 8, 10, 12, 14. Everybody's got an octet. I didn't have to make any double bonds. And that doesn't mean we did something wrong. It just means this doesn't have any double bonds. To finish this, though, I need to put brackets around the structure and put the charge outside the brackets. Because if I don't indicate the charge, it looks like chlorine monoxide, and I've used the wrong number of electrons. So we have to indicate the charge. Any questions? You're going to be drawing a whole bunch of Lewis structures on the worksheet today.